Hello everyone, welcome to Gradeup. So today we are here for the Gear Up JE session, okay, Gear Up JE 2.0, and this session is the PYSP discussion 3, okay. So I will just be waiting for 1 or 2 more minutes. Today I have basically the questions of the subject of SOM, okay, the PYSP of SOM. The strength of materials, I have around 15 questions, okay. So I will just be waiting for 1 or 2 minutes so that more number of viewers can join us, and then we will be starting with the session, okay. So hello, welcome to everyone. Yes, I will just be waiting for 1 or 2 minutes. I have around 15 questions, as I already told you, 15 questions for the day, okay. So there will be good questions for the RRB and SSC JE level, okay. So hello, good, hello, namaste, yes, namaste, great. So yes, okay. So just 1 more minute so that more number of viewers can join, and then I will start with the questions, okay. We will be solving the questions very fast because they are very basic questions. So if you have any sort of doubt in any question, then you can raise your doubts. Otherwise we will be doing those questions very fast, okay. I will be showing you the questions, and then you can give the answer fast, okay. So okay, hello, good evening, vanakkam everyone, okay. So now I think I shall begin with the questions. Question number 1, okay. So let us see what is the question number 1 of the day. This is the question number 1 of the day. It says the strain energy stored in a body due to external loading within the elastic limit is known as. What is that strain energy known as? Stored in a body due to external loading within the elastic limit. First of all, please look into these words. These are important words. That is, it is within elastic limit, and it is talking about the strain energy stored. So the answer for this one, yes, good. I am getting some answers. D is the correct answer for this one. Yes, D is the correct answer. It's called as resilience. Correct. And the maximum energy that is stored, the maximum energy, if there's a strain energy, if you talk about the maximum that is stored, is known as your proof resilience. That is known as your proof resilience. Correct. So this is your proof resilience. Correct. Is it okay? Is it okay? So maximum is known as proof resilience, and within the elastic limit, any kind of strain energy stored, that is known as your resilience. Correct? Okay. Now let us see the next question. Question number 2. The property of the material by virtue of which a body returns to its original shape after removal of the load is called. What is that? What is that property of the material called as? By virtue of which the body returns to its original shape after the removal of the load. That property is known as? Yes, I am getting some answers. All of you are doing great. Yes. All of you are doing great. Yes. B is the correct answer for this one. That property is known as elasticity. That property is known as elasticity. Okay. Any kind of explanation needed into this question, or shall I move on to the next question? This is a very easy question, okay. These easy kind of questions can also come in the examination, okay. So you have to think in that way also, that you always don't try to go for the hard questions, the tough questions. That these kind of questions are also expected in the J level examinations. Okay, no need of explanations, good. Then the third question, the material which exhibit same elastic properties in all directions. Same elastic property in all directions are called. What are those materials called as? Homogeneous, inelastic, isotropic, or isentropic? Answer. Isotropic, okay. All of you are giving me answers. Great, great. Isotropic, okay, great. Okay, absolutely fine. So we have also given the link for the course, that is the paid course, Focus JE Mech, in the description. Okay, if you want, you can go to that course and you can purchase that course from there. Okay, that course, the classes have already started from 10th of June. Okay, so you can do that. Okay, so any one of you have any one of you purchased the course? Okay, has any one of you purchased this course? Okay, so you are most welcome to that course. You can purchase that course. Okay, the link for that is given in the description below. You can go and see. Okay, at least go for the start free trial, see the preview classes and all, and then you will come to know that what we are giving for you. Okay, so that is basically a comprehensive course that will be around a course of which will have the 150 days of classes approximate. Okay, and that every topic, every subject will be covered through classes, study notes, and the quizzes. Okay, so so you can purchase it, no problem. Okay, still the date is on, but there is some discount that is going on for another 1 week, I suppose, and then the course is available for purchase till 15th of July. But it is my advice that those who want to purchase it, you can purchase it as early as possible so that you do not miss the classes. Okay, because if you will miss some kind of sort of classes, then it will be a burden for you to cover those classes later on. So it's better that you go for that course if you want. If you are really interested in that course, you purchase it as early as possible so that you do not miss the classes. Okay, for electronics and allied, we still don't have any sort of plans like this as of now. Okay, and if some sort of plans will be there for EC and all, that will be communicated to you. Okay, don't worry. Okay, so subject wise full test we are not providing as of now. Okay, we have the test series, that is for CBT2 test series. We have the full length test series, not subject wise. Okay, because preparation is it should be a holistic approach. You should follow the holistic approach. Okay, you should be following the holistic approach. You should be focusing on each and every subject. Okay, so we don't have as of now any such test series or any such video course for your subject wise. We are providing it you a full course. Okay, so this question answers isotropic is the correct answer for this one. Okay, so if this is a sort of a material we are talking about, and if this is the point we are considering, in every direction, suppose the properties are E in every directions, then that sort of material is known as your isotropic material. Okay, and if we have another sort of material like this, and if we consider two different points in this, the properties are same in single direction. Okay, at different points in a single direction the properties are same, this kind of a material is known as your homogeneous material. Okay, this is known as homogeneous material. Clear? This is homogeneous, but the first one which I told you, this one was isotropic. Okay, this is your isotropic. The correct answer for this one is your isotropic. Okay, okay, so let us see the next question. This is question number 4. It says, this is a good question, please try it. This is a good question. It says the Young's modulus of a wire is defined as the stress which will increase in length, which will cause the increase in length. Okay, which will, you can say, which will cause increase in length of wire compared to its original length. How much will be that? Will it be half? Will it be same amount? Will it be double? Or will it be 1/4? Is the question clear to everyone? This one? Is this question clear to everyone? First of all, this is the basic thing which you need to figure out. That is this question clear to everyone? Tell me that. Is this question clear? Then we will go for the answers. Double. Okay. Somebody is saying half, somebody is saying double. Okay. So mix answers. Please everyone. More answers. More answers. Then I will confirm what is the correct answer for this one. So answers please. Half. Okay. Answers please. Increase in length of wire compared to its original length. Basically, you have to find out the increase in length. Okay, you have to find out the increase in length. Okay, C, B, A. I am getting the mixed answer. Okay, so let us see this. According to the definition of elastic modulus, that is E equal to sigma by epsilon. Correct? This is your stress. This is your strain. So it says Young's modulus of a wire is defined as the stress. That means this E will be equal to sigma when this will be equal to sigma? When your epsilon will be equal to 1. Clear? When epsilon will be equal to 1. And epsilon is nothing, this is the strain. This is given by change in length over original length. And it should be equal to 1. That means clearly your change in length should be equal to 1. Change in length should be equal to 1. Clear? Change in length is equal to 1. So which will cause the increase in length of a wire compared to its original length. But it is asking the increase in length. So increase in length, if you say it is 1, that means increase in length is equal to L only. Okay, increase in length is equal to L. Same amount will be the increase in length. But if it asks that what will be its final length. Okay, what will be its final length? So final length will be equal to how much? Final length will be equal to your original length plus delta L, and this is L plus L. This will be 2L. But in this question, it is asked increase in length. So increase is your delta only, so that will be equal to same amount. Clear? We are not asking you the final length. We are asking you the increase in length. Okay, this is basically a good question. I will consider this one as a very good question for your JE level. Okay, so is it clear why I am saying that the answer for this one is same amount? See, it is not a proper question. It's basically a kind of question which will create some kind of doubt in your mind, because it's clearly written which will cause the increase in length, okay, of wire compared to its original length. Clearly it's asking you the increase in length. That is your delta L, not your final length. Correct? Okay, now moving on to the next question, question number 5. It says, on the application of a given load, the length of a wire is stated to increase by 1 mm. Correct? That means if your load is P, your delta is given by as 1 mm. Now if the same force, that means if you take another case, P dash is equal to P, is applied to the wire of same material. If this is the case for wire having E, this will have E dash equal to E only. This will have E dash equal to E only because the material is same. But of the length and radius twice the first. Length and radius is twice. So L dash will be equal to 2L and radius is twice. That means your R dash is equal to 2R. Clear? So you know the formula. The formula for delta is given by PL by AE. Clear? Now, if delta dash is given, that will be written as P dash L dash over A dash E dash. Clear? Yes or no? Clear? So P dash is P, correct? L dash is equal to 2L, okay? But what will be A dash? See, A dash will be equal to 4A. Why? Because area is proportional to your square of radius. Clear? Area is proportional to your square of radius. So you can clearly say that A dash will be equal to your 4A because your radius is twice. If radius is twice, its area will become 4 times. Clear? Its area will become 4 times. So clearly you can write here 4A and the E is same. So this is same. Okay. So if you will solve this, you will get PL by 2AE, which is nothing but, this is basically delta dash, and this is equal to delta by 2, which is nothing but 1 by 2, or you can say 0.5 mm. So 0.5 mm is your correct answer. That is B is your correct answer. Okay. Everyone, is this question clear to everyone? Is this question clear to everyone? B is the correct answer for this one. Okay, B is the correct answer. Okay, now moving on to the next problem. It says, in case of a circular section, the section modulus is given by, basically your section modulus is denoted by Z, it is equal to I by Y. And now we have to consider this for a circular section. Give me the answers fast. For the circular section, what will be your section modulus given by? Okay, somebody is saying B. Okay, I will check B. Okay, most of you are saying B, so let us do it. I for the circular section is given by pi by 64 d to the power 4, where d is its diameter and y will be equal to d by 2. So this will clearly come out to be pi by 32 d cube. Okay, pi by 32 d cube. So correct answer is option B, pi by 32 d cube or pi d cube by 32. Okay, clear everyone? Is this question clear? This is a very simple problem. Very simple problem. Okay, nothing more simpler than this can happen in or can be asked in your technical portions. Okay, this is a very simple problem. So answers, is everyone clear with this? Shall I move on to the next question? Is it clear to everyone? Please confirm. Is everything clear to this one? Yes. Okay. Now seeing the next problem, it says the strength of the beam mainly depends upon. The strength of the beam mainly depends upon which? Section modulus, its weight, bending moment or center of gravity of the section. Answers please, fast, fast. Don't take more than 10 seconds in these sort of questions. A, yes, the strength depends upon your weight. Sorry, section modulus. Yes, section modulus, the strength depends upon your section modulus. Absolutely fine, absolutely fine. Okay, seeing the next problem now. Question number 8. Question number 8, it says, two simply supported beams A and B, there are two beams A and B, has the same length L and subjected to equal bending moment M. The stress induced in the beam A and B, the stress induced in beam A and B are sigma A and sigma B respectively. If the cross section of the beam A is B into B by 2 and for the beam B it is, and that of beam, sorry, there should be B written here. Okay, that of beam B is B by 2 into B. Clear? Then correct relation between sigma A and sigma B is answers. See, you know, stress is equal to M by Z. And when this M is a constant, because it says that equal bending moment is there, so stress will be proportional to 1 by Z. Okay? Yes or no? Yes or no? Clear? Then what you can do in this one is simply the first one for beam A, the cross section is given as B into B by 2. That means it's something like this, that this is given as B and this is given as B by 2. In this case, you can find out the Z. Z will be equal to what? 1 by 12. If you consider the Z along this axis, that is 1 by 12 B into B by 2 whole cube divided by your Y. Y will be B by 4. So you will get this value as B cube by 24. Clear? You will get this as B cube by 24. Okay. Then this one was for A. So you can write here this was ZA. Okay. And if you talk about ZB, for the ZB, the beam looks somewhat like this. The beam would look somewhat like this, that this is your B by 2 and this is B. If you will find out the ZB, you will get this value as B cube by 12. Clear? So clearly you can say that ZB is equal to twice of ZA, and since the stresses are inversely proportional, so you can clearly write from here that sigma A will be equal to twice of sigma B. That is your option A is correct. Option A is correct, not B. Okay, that's why I told you that since they are inversely proportional and the Z of B is greater than, or Z of B is twice of Z of A, but stress will be more in A. Why? Because they are inversely proportional. They are inversely proportional. Okay. So clear everyone? They are inversely proportional. Is it okay everyone? Yes or no? Is it okay? Please tell me, is everything okay with this? A is correct answer for this one. A is correct. Stress is equal to M by Z. That is not M by R, that is M by Z. Okay, that is M by Z. That is basically which we have derived from our basic bending equation. The bending equation says that M by I is equal to sigma B by Y is equal to E by R. This is our basic bending equation. So if we combine these two parts, we get sigma B is equal to M. This Y will go here, so this will become Y, My by I, or if you take that Y down, it will become M over I by Y. Okay, and M by I by Y is nothing but your Z. That way it becomes sigma equal to M by Z. Clear? See if you can try it along Y section as well. Okay, but basically we are saying that it's a simply supported beam. So generally what we do, generally unless and until it's stated, we generally take the your axis along the horizontal axis only, unless and until it is stated. If it is mentioned that we have to take it along the y-axis, then it will be clearly mentioned, because generally in the cases of beams and all, we say that the load is being applied vertically only. Okay, the load is not supposed to be acting horizontally, but if it is the case, if it is the special case in which the load is acting in the horizontal direction, then it would be mentioned. Otherwise, you don't worry about it. Just take your load according to the general conventions that it is acting in the vertical direction and solve the problem. Okay? Is it okay, everyone? Is it okay to everyone? Shall I proceed to the next question? Is this question clear to everyone? Yes or no? Please tell me. Okay, so now see the next problem. It says Rankine's theory of failure. Rankine's theory of failure is applicable for which of the following types of materials? Rankine's theory of failure is applicable for which type of the material? First of all, you should know what is this Rankine's theory. Rankine's theory is your first theory of failure, that is also known as MPST, that is maximum principal stress theory. This is your maximum principal stress theory, and this theory is the best theory for your brittle material. This theory is your best theory for brittle material. But if it is asked for ductile material, for ductile material the best theories are your shear stress, maximum shear stress plus MDET, that is maximum distortion energy theory, okay, or also known as maximum shear stress shear stress energy theory. Okay, this theory is also known as your von Mises. Okay, this theory is also known as your von Mises, and this theory is also known as your Guest and Tresca's theory. This is your Guest and Tresca's theory. Clear? Okay, clear. MSST is Guest plus Tresca, MDET is your von Mises, and the theory which is best suited for brittle material is your MPST. And why it is best suited? Because this is the brittle materials are weak in tension. The brittle materials are not weak in shear, they are weak in tension, whereas your ductile materials are weak in shear. Okay, I'm giving you the extra informations. If you want, you can note it down as well, because anything can be asked in the examination. Okay, so we don't have that much legacy that we can leave anything. Okay, so basically that's why I'm giving you each and every point, so that you can, what you can do, you can follow, you can have everything with you, every concept and all, and so that you can note down anything, because anything can be asked. Okay, now moving on to the next problem. This says, this is the question from the topic of principal stress strain. Principal stress strain, it says that at the principal planes, what happens? The normal stress is maximum or minimum and the shear stress is 0. The tensile and compressive stresses are 0. The tensile stress is 0 and the shear stress exists. Please write down one word here, that shear stress exists and no stress acts. So what is the answer for this one? Okay, what is the answer for this one? Tell me fast, what is that happens at the principal planes? What is true about the principal planes? Yes, principal planes are those planes at which your normal stress is maximum or minimum. Maximum stress is minimum or maximum, but the shear stress is clearly 0. The shear stress is clearly 0. So the correct answer for this one becomes your option A. Option A is your correct. Okay, yes, absolutely fine. Okay, yes. Now moving on to the next problem. It says a circular shaft can transmit a torque of 13 kilonewton meter. Okay, what about vice versa means? What about vice versa means? See, first of all, let us see this question. A circular shaft can transmit a torque of 13 kilonewton meter. If the torque is reduced to 12 kilonewton meter, then the maximum value of bending moment that can be applied to the shaft. You know, if there is both the bending and torsion that are being applied, so the formula comes out to be, that is T equivalent is equal to m square plus T square. This is given to you as 13. This T square has been given to you as 12. So this will be 12 square plus m square. Okay, so simply squaring this side, you will get 169 minus 144 is equal to m square. You will get this value as 25, and you can say that m will be equal to 5. That is, C is your answer. Okay, this is basically the question which uses the concept of your equivalent torsional moment. Equivalent torsional moment. Okay, the correct answer for this one comes out to be option C, 5 kilonewton meter. Okay, is it okay to everyone? Shall I move on to the next question? See, shear stress is maximum and normal stress is 0. There is no such plane which exists. There are 3 planes which exist. One is your principal planes, on which the normal stresses are 0. Normal stresses are either minimum or maximum, and the shear stress are 0. Then there is second plane, that is your shear of maximum, plane of maximum shear stress. On the planes of maximum shear stress, your shear stress is maximum, but your normal stresses exist. Normal stresses exist. They are not zero. Then comes your third kind of a plane, that is known as your planes of pure shear. Planes of pure shear, in what happens in those? Only shear stress exists. Only shear stress exists. It may or may not have its maximum value, but only that exists. Clear? So that is about your vice versa case. Okay, now move on to the next problem. It says a solid shaft transmits 44 kilowatt of power at 700 RPS. 700 RPS. Okay, calculate the torque produced in Newton meter. You have to find out, or you have to tell me the torque produced in Newton meter. Okay, clearly the answer for this one. See, that is to be understood by practicing, because this is not the question that I have made from my side. This is the question that was the previous year asked question. They have asked it in this way only. Okay, this is the previous year question which I have told you about the torque and all. From there you can make out. If you will practice, you can make out. Okay. Answer for this one. See, it says power is given to you as this. So this is P and this is your N. So simply you know that P is equal to T into omega. So power you can write 44, but it is given in kilowatts. So convert it into watts. This, and T you have to find out, and omega is given by 2 pi N. Okay. No, you don't have to change it into RPM, because what we used to find out, because here it is given in watts. Okay, so you don't have to change it. Generally we use the formula here that this is 60 when this is in RPM, but it is already given here in RPS, so no need to use this. Okay, leave it. So simply put the values 44 into 10 to the power 3, and that is T into 2, and the value of pi is your note 22 by 7 into the value of N is given you at 700. Okay, so this will get cancelled, this will be 100. 22 into 2 is 44, so this gets cancelled. So you are left with T equal to 1000 divided by 100. So you get the answer as 10. You get the answer as 10. Correct? You get the answer as 10, or you can say the correct answer is option D. Okay? Correct answer is option D. Okay, now I am moving on to the next problem. Question number 13 for the day. It says the effective length of the column with one end fixed and the other end free is. This is the case of one end fixed, other end free is, compared to its original length. What will be compared to its original length? The effective length of that case. Basically we are talking about LE, that is the effective length. So effective length will be equal to how much? Tell me the answer for this one fast. Effective length. See, you know there are basic conditions. LE is equal to alpha into L. So you have to basically find out the value of alpha. Okay, that is your length fixity coefficient. Correct? And you know, for the cases of both ends hinged, both ends fixed, fixed and hinged, fixed and free, the values of alpha are 1, 1 by 2, 1 by root 2 and 2. So clearly you can write here that LE, that is effective length, will be equal to twice of L, or you can simply say it is twice its length. Correct? Okay, is it correct? So B is the correct answer for this one. Now moving on to the next problem, the second last problem of the day. It says a long circular cylinder has the diameter D. This is the diameter D and it is having the length L. So the slenderness ratio of the column is. You have to tell me about the slenderness ratio of the column. Answers fast. Slenderness ratio. It is generally denoted by S, that is capital S. So answers for this one fast. Slenderness ratio. Don't go for L effective. Why I am telling you this? Don't go for L effective, because here nothing has been mentioned to you about the end conditions. Don't worry about the end conditions. Okay, because it is not mentioned. So simply take your L only. Okay. See, it is asking you the slenderness ratio. Slenderness ratio is given by L by K. This is your radius of gyration. This is given by I over A. Okay, this is given by I minimum. Generally it is given by I minimum by A, the root of this. But since this is a circular cross section, so I minimum will be same. I minimum will be same. So this will be simply equal to pi by 64 d to the power 4 divided by A, that is your area, that is pi by 4 d square. Okay, so this you will get as pi by 6, sorry, the pi will get cancelled. You will only have d square by 4. D square by 4, sorry, d square by 16. And d square by 16 is equal to your K, the root of this, so this will become equal to D by 4. D by 4. Okay, clearly you can say. So S is equal to L by K. So this is your L and K value is your D by 4. So this will be 4L by D. That is option D is correct. Option D is correct. Not A, B or C. Please look into it. Not A, B or C. D is correct. Okay. Is it clear to everyone this question? Is it clear to everyone? This was a good question. Basically, I will consider this as a good question. Is it clear to everyone? Please tell me. Yes, L over D by 4, or you can also write it as 4L by D. Yes. So D is your correct answer. I will be now moving on to the last problem of the day, the question number 15. Okay, see the last problem. It says a body weighing 100 kg. This is the mass of the body that has been given. Sorry. This is the mass of the body that has been given to you. It says falls 8 centimeter and strikes a spring. This is the spring that is given in terms of spring constant. The deformation of the spring will be. What will be the deformation of the spring? What will be the concept that you will be using into this one? Please tell me. What will be the concept that you will be using? Basically, you have to equate two energies into this. This much I am giving you the hint. Okay? This much is the hint that I am giving to you, that you have to equate two energies into this one. So which kind of energies you will use? Okay, which energies you will use into this one? See, don't go into that sudden load and impact load. That is not relevant. Simply you have to use basic concept of mechanics. If you have the basic concept of mechanics, this question can be solved. Simple thing is that there is a spring on which your body is falling. So falling body will have its potential energy. So potential energy, and that will be equated. That will be potential energy, not kinetic energy. Potential energy. Why potential energy? Because there is some spring that is placed. Let us say that this is a sort of a spring and the body is falling from some height. Okay, it is falling 8 centimeter. So this is the height at which the body is falling. So your falling body will have its potential energy, and that will be equal to your kinetic energy of spring. Okay, you don't have to consider the kinetic energy of the falling body. You just have to consider the kinetic energy of the spring. So potential energy will be equal to, let us say that this body falls up to this one, and this is the H. Okay, this is H and this is your X. Okay, because when the body will press on the spring will also go somewhat down, and they both will travel some distance that I have taken as X. Okay, that I have taken as X. So potential energy will be equal to M into G H plus X, and this will be equal to half K X square. Clear? So M is given to you as 1000. You can use the value of G as 9.8 H. But please see, take all the values in MKS units only. This is given H as 8 centimeters. So take it as 0.08 plus X. Okay. And this is equal to half. The value of K has been given to you as 500 kg per centimeter. Okay. You have to convert it into your specific units, that is in Newton per meter. So converting kg into Newton, how you will do? Kg into Newton will be given by 500 multiplied by 9.8, and if it is per centimeter, you have to convert it into per meter, then again you have to multiply it by 100. So this comes out to your value of K. Clear? So value of K will be equal to 500 into 9.8 into 100, and this will be multiplied by X square. So if you will solve this, you will get the quadratic equation in forms of your X square minus X minus 0.08 equal to 0. This will be the kinetic energy that this will be the quadratic equation that you will be getting. From this you will be getting two values of X. One will be 0.08 and one value will be minus 0.04. So discarding this negative value, you can just take this positive value, and this will be coming in meters. So it is asked in centimeters. So just multiply it by 100 and you will get the answer as 8 centimeter. 8 centimeter, or A is your correct answer for this one. Is everyone okay with this question? Is everyone okay with this question? Yes or no? Please tell me fast, because this is the last question of the day. Okay? Is it clear to everyone? This is the last question of the day. Okay? Clear. Okay. So thank you all for being a part of this class. Okay? I hope you are getting benefited from this Gradeup JE course as well, the free course that is running on our YouTube. And if you want to prepare fully with us for the CBT2, there is a Focus JE Mech course. It has started only day before yesterday. Still you can access all the classes and all those study notes and quizzes. What you have to do, just click on the link given in the description below. Okay, go. There is the full schedule for this RRB, this Gear Up JE as well. That is also given on the description. You can see that. Okay, when we will be coming live and all. So basically, if you want to prepare full, means in a full preparation mode, you have to do with for CBT2 with us. So there is basically the course that is Focus JE Mech course, that it is given in the description below. So what you do, just click on that link, enter into the classroom, enter into the course, and at least start your free trial today. Okay, start your free trial today, check the course, and then you can also have the options available for its purchase. So it's better that if anyone interested in that, you can purchase that course very soon. Okay, so that you do not miss the classes, you can purchase it as early as possible. Okay, and CBT1, most of you are thinking about when will be CBT1. So we are expecting the CBT1 to be somewhat around during 15th September. But even if the course will not be, means if the course will be before to that, means it will be either in the end of August or in the before 15th September. So even in our paid course, we will be finishing off the syllabus before time. Okay, well before time, so you don't have to worry about it. It's my suggestion that if you can try our course, okay, go to the classroom by the link that is given in the description below. You can try that course, okay? And so see you in the next session. Till then, prep smart, score better, go grade up. Thank you.